Welcome to ePadasala lecture series in computer science. Last module we discussed about some of the fundamentals of greedy approach. In this particular module we are going to discuss more about the greedy algorithms. The learning objectives of this particular module is to review some of the fundamentals of greedy algorithms that were discussed in the last module. We will discuss about one of the most important problem in computer science, that is the knapsack problem. We are going to discuss about how greedy approach can be useful for solving this particular problem. Then we will discuss about the basics of compression theory, and especially we are going to discuss about the greedy approach for solving the problem of coding using the algorithm called Hoffman code algorithm. So, what is the greedy algorithm is all about? Last module we discussed the fundamentals. I said for some of the optimization problems, the solution involves taking a sequence of decisions, and a greedy algorithm always makes the decision that is looking best at the present moment. In other words, it is locally optimal. Last module we discussed that greedy approach is useful for solving optimization problem. Probably you can recollect what the optimization problem is all about. Any optimization problem will have an objective function, then it will have some sort of a constraint, and it will have some sort of a extremum requirements like maximization or minimization. I was telling you that for a given problem there may be n number of solutions. They are called candidate solutions. Out of all the solutions, some solutions are the best solutions that we are calling as the optimal solution. The main objective of greedy approach is to find the optimal solutions. Sometimes the greedy approach may not be able to solve the problem, and it may give some suboptimal results. In spite of that, greedy approach is very popular because they are considered to be more faster, and many times they are giving optimal or suboptimal, in other words near optimal solutions. So, first we will discuss about one of the most important problem called knapsack problem. So, let us begin with a small story. Let us assume that a thief has entered into the museum. The museum has got fabulous paintings, sculptures and jewels, and let us assume that every item is having certain weight as well as the profit, and unfortunately the thief has brought only one single knapsack. Knapsack means a large bag. So, the issue is the thief cannot take all the items. So, he will look for the items that can fetch the maximum profit for that particular person. So, in other words, the problem of knapsack is about how to maximize the whole. This is called a loading problem. In fact, many problems in computer science can be modeled as a knapsack problem, where you have an objective function. The objective function is to maximize, and this maximization of profit is possible by the optimal packing of all the items. So, let us discuss about how to apply the greedy approach for this particular problem. So, the important gist of that particular story is like this. A knapsack is given. So, the knapsack maximum capacity is W, That means at no point of time the capacity of the knapsack can go beyond this W, and we are given a set of items. There are n items that are available. Each item is having a weight Wi, and it is having a profit or value called P of I. So, let us assume that the weight, profit and W are all integer values. So, the problem of knapsack is very simple. We have to pack the items into the knapsack, so that the profit is going to be the maximum. So, this is what the knapsack problem is all about, that is how to achieve the maximum profit. So, this problem is so popular, and in fact, in computer science we study about two variants of the knapsack problem. One is called 0-1 knapsack problem, where the items cannot be divided. In other words, the thief has to take the entire item or he has to leave it. In other words, if there are electronic goods available, we can't break an item. So, that means either we have to take the item into the knapsack or we should leave that particular item. The other variant is called the fractional knapsack problem, where we can take what is a partial content of the given item. Suppose if the item is a powder or liquid, then we can take a small part of the item into the knapsack. It is conceivable that fractional knapsack problem is a easy problem that can be solved using the greedy approach, and 0/1 knapsack problem is considered to be a toughest problem in computer science. Fine, we will take the fractional knapsack problem and let us try to give a mathematical formulation. The mathematical formulation is like this. So, xi represents the fraction of the item that are loaded into the knapsack, and the corresponding profit is going to be P of I, and every item is having a weight W I. So, that means now you can see that the mathematical formulation of this problem is maximization of P I and xi, where the aim is to maximize the profit, subjected to the constraint that the weight of the items that are loaded into the knapsack should be less than or equal to W. So, xi ranges from 0 to 1 and I ranges from 1 to n. That means there are n items that are available. This is the mathematical formulation of the problem. So, this is the graphical illustration of how it really works. So, we assume that the bigger bottle is going to be the knapsack, whose weight is given as 20 kg, and we are given 3 items, and items weight as well as the profit are given in the figure. So, the knapsack problem is we have to load the items of the smaller things into the larger thing, so that we can get maximum profit. This is the fractional knapsack problem. So, that means we can take a part of the item onto the knapsack. Imagine like this, I will go according to the profit. So, just to see this particular diagram. So, you can see that the profit is given. So, for item 1 the profit is $24, item 2 profit is $20, and item 3 profit is $16, and the corresponding weights are given as 14, 18 and 10. Suppose let us say if I go according to the profit, you can see that item 1 is having the maximum profit. So, I am just loading the knapsack with item 1. The item 1 weight is 16 kg, therefore, it becomes 20 minus 16, that is going to be 4 kgs, and you can see that it is going to be 14 kgs. So, that means it is going to be 20 minus 14, that is going to be 16 kgs, and the remaining thing I am loading with the item 2. So, that is going to be 6 by 18 and the remaining capacity is 0. So, the total profit if we calculate, it is coming as 30.66. Suppose if we are going according to the weight. So, if I go by the weight, then I will load item 3 because it is having the least weight. So, the remaining capacity is 20 minus 10, it is going to be 10. So, the next least weight is item 2. So, therefore, I am just loading the remaining capacity with item 2. So, that means it is going to be 10 by 18. So, the capacity is full now. So, that means loading of the first item is not possible. In this case, you can see that the profit is going to be 27.11. So, we will try one more thing, that is we will take the ratio of profit and weight Pi divided by Wi. So, let me calculate the ratio of all the item. It is coming as 1.71, 1.11 and 1.6. So, let me put it in the ascending order. So, that means the item that is having the maximum profit and weight ratio is item 1. Therefore, I am loading the item 1. So, that means 20 minus 14 is 6. So, the next item where profit to weight ratio is very high is item 3. So, therefore, for the remaining capacity of the knapsack, I am filling it with 3 by 5. So, loading of the what you say item 2 is not possible. So, in this case the total profit is going to be 33.6. So, this is a comparison table. So, you can see that according to the profit means it is coming as 30.66, by weight it is coming as 27.11, and the ratio of profit to weight it is coming as 33.6. So, now you can come to a conclusion that the best criteria for selection of item is going to be the ratio of the profit to weight. So, the greedy components are selection procedure. It is based on the ratio of Pi by Wi. Feasibility check is at no point of time the weight should cross the W, and the solution check is whether all the instances are checked or not. So, the informal algorithm is going to be like this. So, I am going to sort the items in the decreasing order of profit to weight ratio. While there is still room in knapsack, I am going to consider the next item and take as much as possible. The formal algorithm is going to be like this. So, you have algorithm greedy knapsack W, then n are items with the profit which is given in the array P, and it is given the weight is given in the array W, and the ratio is Pi by Wi. So, you can see that initially the solution vector is initialized to 0. So, what I am trying to do is I am taking the ratio. So, whenever there is a possibility is there, so I am putting that into the knapsack. So, I am taking the remaining item, based on that I am taking the fractions and I keep on filling the knapsack. So, whenever I am filling the knapsack with the particular item, the corresponding vector is going to be 1. This is the formal algorithm for that. So, this is a small example of how it really works. So, you can see that there are 3 items. So, you have weight profit ratio. So, as we discussed earlier, the best criteria is profit to weight. So, I will compute this. So, you can see that it is coming as 3, 2 and 4. So, you can see that for P 3 by W 3 it is going to be 4. So, that means I am going to fill that, then I am going to fill with the next one, and I am filling the remaining thing with the next item. So, the profit is coming as 48. This is the answer for this particular problem. So, what is the complexity analysis? So, this involves sorting of items. So, that means it is going to be order of n log n, and if n items are there, the complexity is going to be order of n. So, this is far better than the brute force approach which we discussed already. It is going to be order of 2 power n. Therefore, you can come to a conclusion that greedy approach is far more better than the earlier ones. As I said earlier, fractional knapsack problem is easy to solve, but 0 bar 1 knapsack problem is a considerable difficult task. So, for that we will go for dynamic solutions. One more algorithm we will discuss today as part of this particular module is the Hoffman algorithm, which uses the greedy approach. This algorithm is very much useful for data compression. So, compression is a very important topic where we are talking about reduction of size of data. So, by that we mean that the number of bits that is required to represent the data is reduced, and the advantage of this data compression is that we can reduce the storage space that is necessary for storing the files, as well as we can reduce the transmission cost, latency and bandwidth. So, because of this particular reason, compression is very important, and Hoffman code is considered to be one of the most important algorithm in data compression. So, the logic is very simple, optimal coding. So, let us assume that I want to transmit 3 symbols ABC. So, transmission requires encoding of these symbols as a code by giving some address. So, that means 3 symbols are there. So, that means let us assume that if I go for fixed length code, so that means I can go for 00, 01, 10 and 11. So, even though there are only 3 symbols, so I require at least 2 bits to represent that. So, that means in fixed coding, if I go for this, and if I want to transmit a file that consists of 1000 characters, then 2000 bits are required in order to transmit this. So, the main issue here is fixed length code, which is suboptimal. So, that means it is not very optimal. So, the logic is very simple. Why can't we go for a variable length code where every symbol will not have a fixed address, but rather a variable address. So, we require some sort of a methodology for that. So, that is given by Hoffman. So, the idea is very simple. We will use short codes for more frequent characters and long codes for less frequent. So, in other words, we are looking for some information content, and if a symbol comes very frequently means, so that means it is not very important. So, we will use very short code to represent that, and if a symbol comes very rarely, that means information content is very high. In that case, we will go for the longer code. So, we will just give some important definitions. A code. So, a code is the mapping of character of the alphabet to a binary code word. A prefix code is a code such that no code word is the prefix of the another code word, and this is assigned using a encoding tree. So, encoding tree represents the prefix code, where every external node stores a character, and the code is given by the path from the root to the external node, where every edge is given 0 on the left hand side, 1 on the right hand side. So, we will take a very simple example how to do this. So, I am taking 5 symbols, and every symbol is associated with a frequency 2, 6, 9, 2, 7. Say for example, if I take a string like AAB, you can say A occurs 2 times and C occurs 1 time. So, we can calculate frequency, we can calculate the probability also. See, Hoffman code works with both frequency as well as the probability. This algorithm uses the greedy approach. The greedy approach is like this. So, we have to go for the best local decisions. So, the logic is very simple, like a greedy man, we are looking for the smallest symbol and we are trying to combine. So, given a option, we go for the least frequency symbols. The least frequency is A and H. So, I am trying to combine this. So, this is 4. So, now I have to consider the best possibility for 4, 6, 9, 7. So, that means you can see that 4 and 6 are the best possibilities. So, I am getting 10. So, next I have to consider 10, 9, 7. So, the best possibility is 9, 7. So, it is 16. So, when I combine that I am getting 26. So, as I said earlier, this is called an encoding tree, where you can see that every external node that is given in green color is representing the symbol, and the binary code of every symbol is obtained by tracing the path from the root to that particular external node. So, now you can see that A is nothing but 1 1 1, you can see that H is 1 1 0, and C is 1 0, then E is 0 1, and I is 0 0. So, you can see that this is a variable code. So, that means you can see that all the symbols are not having the same length of code, but rather it varies according to the frequency. So, this is the logic. So, the symbol A occurs frequently, therefore, it is having more length compared to symbol, let us say E or something. Okay. So, this is the Hoffman code that we have. So, imagine like this. So, I want to transmit the message ACE across the channel. So, that means for A it is 1 1 1, and C it is 1 0, and for E it is 0 1. So, that means I will be sending the binary stream 1 1 1 1 0 0 1 across the channel. So, across the channel this bit stream will be received. So, the question is how to interpret this. Okay. So, the logic is very simple. The same encoding tree that we used as part of the sender will be used to what is a decode. So, in decoding we read the bit stream and we will use the encoding tree to decode the file content. So, let us see what happens. So, first I am getting A, then I am getting A again, then I am getting 1. So, that means you can see that 1 1 1 is nothing but A. So, next I will be getting 1. So, it is 1, then I will be getting 0. So, that is going to be your C. So, next is 0. So, 0 and 1, that is going to be E. So, that means now you can see that the ACE is received exactly as we have transmitted, and there is no information loss. This is the beauty of the Hoffman code. But there is only one problem, that is the prefix property needs to be satisfied. So, what is a prefix property? Prefix property says that no code is should be the prefix of another code. For example, let us say if for one symbol it is 0 0 0 hypothetically, then this should not be the prefix for any other code like 0 0 0 1. Why? Otherwise there will be a lot of confusions. So, the message will be misinterpreted. For example, if 0 represents character A, 0 1 represents let us say character B, then how you will interpret 0 0 1. So, this is where problem comes. So, this leads to the multiple way of interpretation that may cause problems. Fortunately, the Hoffman code is satisfying this property. So, that means there is no confusion at all. This is the informal algorithm. Take all the symbols along with the frequency. So, greedy approach, choose two lowest frequencies and combine them. It will produce a new node where the frequency of these two symbols are added. Then this process is getting repeated till we get the root. So, this is the informal algorithms. So, you can see that initially all characters are assigned as a single node, then we will keep on adding all the things, and so we will continue this procedure till we get the entire tree. So, this is a formal algorithm. So, you can see that the priority queue is used. So, you can take the character C. So, what we are trying to do is we are putting everything into the priority queue with f of C as the key. Then what we are trying to do is we are trying to extract min from the priority queue. So, two least frequency items are sent as the output, then we are creating a new node, then we are adding the frequency, we are putting that left hand side we are assigning as 0 and right hand side we are assigning as 1. Then we are adding this z onto the queue and we are repeating this process from 1 to n minus 1. Therefore, at the end of all the iterations you have the encoding tree. So, what is the complexity analysis? Complexity analysis is the complexity of handling the heap. So, it requires order of n log n. So, that means you have n items. So, that means the total complexity time is order of n log n. In summary, we can come to a conclusion that greedy algorithms are useful for solving the optimization problems. Knapsack problem is very important. Greedy approach is very useful for solving the fractional knapsack problem, and Hoffman coding is very effective in finding the optimal code. Thank you very much. Next module we will be discussing some more problems that are coming under this particular category. Thank you very much.